Have you ever encountered something in nature so astonishing, so uniquely strange, that it felt unreal? Our planet is an endless gallery of wonders, consistently showcasing breathtaking light displays and powerful artistry. We admire the beauty and feel the wonder, yet rarely do we consider the most crucial question: what's really taking place? Have you ever gazed at the swirling northern lights and pondered the cosmic mystery our world is sharing with you? Or seen a photo of a volcano paired with its own personal lightning storm and thought, how can that even occur? The answers lie within the stories told by solar winds, atmospheric gases, frozen crystals, and even living light. They are more astonishing than one can imagine. Today, we are not merely observing nature's wonders, we are unveiling the science that brings them to life. The cosmic dance, Aurora Borealis and Australis. Alright, stargazers, let's begin with one of the most spectacular shows Earth offers, the aurora. In the northern regions, it appears as the Aurora Borealis, or Northern Lights, while in the south, it's the Aurora Australis. For ages, these lights were wrapped in myths. Vikings believed they reflected the shields of Valkyries. Indigenous cultures thought they were ancestral spirits or celestial creatures dancing in the dark. Indeed, they are beautiful. Yet the reality, the science, unfolds as an epic narrative across the solar system. So, what's this cosmic secret? The tale commences about 93 million miles away, at our solar system's heart, the Sun. Our star isn't merely a calm orb of light, it's a fierce nuclear furnace, relentlessly emitting a flow of charged particles known as solar wind. Consider it a constant, invisible hurricane radiating outward. Sometimes, the Sun generates more than just a cosmic breeze. During massive events like solar flares or coronal mass ejections, it expels enormous clouds of particles into space at incredible speeds. Most of this storm merely sweeps past the planets. However, when it reaches Earth, something extraordinary happens. Our planet wields a secret weapon, an invisible barrier called the magnetosphere. This magnetic field, produced by molten iron in our planet's core, deflects nearly all of the solar wind, shielding us from radiation. But it doesn't block everything. The magnetosphere channels some of these energetic particles, primarily electrons and protons, towards the north and south magnetic poles. It's here that the magic unfolds. As these particles, energized from their lengthy journey, collide with atoms and gas molecules in our upper atmosphere, remarkable events happen. Imagine cosmic billiards. The solar particle acts as the cue ball, striking a stationary object, an oxygen or nitrogen atom. The atom absorbs energy from the collision, becoming excited and jumping to a higher energy state. However, it cannot remain there. To return to normal, it must release excess energy, resulting in the ejection of a tiny particle of light, a photon. Now, imagine trillions upon trillions of these collisions happening simultaneously. This creates the aurora, a vast, glittering curtain of light. We are witnessing solar wind interacting with our atmosphere. What about those stunning colors? They're not arbitrary. The hue entirely depends on which gas is impacted and at what altitude. The vivid, ghostly green we often see? That occurs when particles collide with oxygen atoms between 60 and 120 miles up. If the particles are highly energetic and impact oxygen at even greater heights, above 120 miles, we observe a deep, beautiful red. The blues, purples, and pinks occasionally seen at the curtain's bottom? Those arise from nitrogen molecule collisions. When you glimpse an aurora, you are witnessing a direct, visible connection between the Sun and Earth. You're observing a cosmic wind concluding its long voyage in a stunning, silent light symphony. This serves as a reminder that our planet exists within a dynamic, interconnected cosmic system. The living light, bioluminescent shifting from sunlight-driven displays, we now explore the dark depths of our oceans. What if I told you that you don't need to gaze at the sky to witness a light spectacle? What if the light is alive? This captivating phenomenon is bioluminescence, transforming our dark oceans into living galaxies. Picture immersing your hand in the ocean at night. With each movement, the water erupts in a radiant blue-green glow. It clings to your skin like liquid stars before fading. This isn't magic, it's a brilliant, desperate cry for survival from billions of tiny creatures. The artists behind this phenomenon are typically single-celled organisms known as dinoflagellates. These plankton drift through the water, and in select locations, like Puerto Rico's famous bioluminescent bays, conditions are perfect for their massive gathering, hundreds of thousands in 1 gallon of water. So, how do they produce light? How can a living entity create its own illumination? It resembles a tiny biological glow stick rather than a simple glow-in-the-dark sticker. Each dinoflagellate contains 2 vital chemicals, luciferin and luciferase. Consider luciferin as fuel and luciferase as the engine. They typically remain separate. But when a dinoflagellate is disturbed, by a wave, a fish, or your hand, the cell membrane stretches. This stretching initiates a chain reaction. A signal prompts tiny compartments within the cell to mix these chemicals. The luciferase enzyme combines oxygen with luciferin fuel, generating a quick burst of blue-green light. This flash lasts only 1/10 of a second, but when billions ignite simultaneously, the ocean seems to shimmer. But why this effort? The reason is stark: survival. For a microscopic organism on the food chain's lower end, life is a continual struggle to avoid being eaten. Bioluminescence serves as a defensive strategy. Scientists refer to this as the burglar alarm theory. Consider a small crustacean that might snack on a dinoflagellate. Disturbing the water triggers a flash, illuminating the dinoflagellate. This surprises the predator, giving the plankton a chance to escape. It's even more clever than that. The light also draws attention. A larger predator, like a squid or fish, may notice the flash and come over to inspect. It will ignore the small plankton and instead consume the creature that was trying to eat it. The light becomes a luminous distress signal, turning the dinoflagellate's predator into its own prey. This phenomenon of living light is found in many creatures, from the familiar glow of a firefly to the sinister lure of an anglerfish in the deep ocean. Bioluminescent fungi even cast an otherworldly glow on forest floors. Thus, the next time you encounter that enchanting glow in the water, remember what you were witnessing. It's not merely a chemical reaction. It's life and death communicated in light, a galaxy of tiny cries igniting the night. Pillars of heaven, light pillars transitioning from living light in our oceans. Let's now revisit the sky. However, this time, the magic arises not from 93 million miles away, but from the very air surrounding us, frozen in place. Imagine a still, frigid winter night. Glancing over a city, you see it, ethereal, vertical beams of light stretching skyward from every streetlight. They appear as something from a science fiction movie, tractor beams from an alien craft. These are light pillars, one of nature's most exquisite illusions. So, are these beams genuine? Is light truly shooting upward into the sky? Not quite. A light pillar is not actually above the light source. Its vertical appearance is an optical illusion, a grand mirror game orchestrated by the atmosphere itself. This phenomenon requires a specific recipe. First, the air must be extremely cold, far below freezing, and notably still. In such conditions, moisture in the air forms tiny, perfectly flat hexagonal ice crystals. Because the air remains still, these crystals don't tumble, they float horizontally, like billions of microscopic dinner plates drifting along. Each of these diminutive crystals acts as a mirror. Now, envision a streetlight on the ground. Light emitted from the lamp travels upward, striking the flat bottom of one of these ice crystals and reflecting back down toward you. But why does it appear as a pillar? Because the crystals are suspended throughout a large volume of air, varying in heights. You are witnessing the collective reflection of millions of crystals. However, you only perceive the reflections from the crystals that align perfectly to direct the light toward your eyes. All those precisely positioned crystals align vertically, producing the illusion of an unbroken column of light. A fitting analogy is the sun's reflection on water. Rather than seeing one point of light, you observe a continuous, shimmering line on the water's surface. Each ripple reflects the sun, but you only see the reflections that align to reach your eyes. Light pillars operate in the same manner, vertically using ice crystals instead of water ripples. The color of the pillar corresponds to the hue of the light it reflects. Orange streetlights produce orange pillars, white headlights create white pillars. What we observe isn't supernatural. It's a stunning and precise harmony of physics. It demonstrates that under the right conditions, simple elements, light and frozen water, can unite to create something utterly otherworldly. The primal storm, volcanic lightning. Nature's might can be subtle, akin to a trick with mirrors and ice. Yet sometimes, its beauty emerges from utter chaos. Imagine a volcano erupting, a mountain disintegrating, ejecting a massive plume of ash and rock miles into the sky. It's a fearsome sight. Suddenly, something even more astonishing occurs. Within that swirling, dark cloud of ash, brilliant flashes of lightning appear. This phenomenon is volcanic lightning, or, as it's sometimes referred to, a dirty thunderstorm. This naturally raises an intriguing question: how? Lightning is typically generated from thunderclouds packed with water and ice, not a plume of scorching ash. How can a volcano create its own lightning storm? The answer lies in the sheer ferocity of the eruption. A normal thunderstorm accumulates its charge gradually. In contrast, a volcano instantaneously creates a charged environment. When it erupts, it releases a tumultuous mixture of rock fragments, ash, and gas from deep within the earth at breakneck speeds. As countless particles are propelled skyward, they collide violently, generating massive static electricity. This operates on the same principle as rubbing a balloon on your hair, causing it to stick to a wall, only at catastrophic levels. During these collisions, electrons are stripped from some particles while being transferred to others. At the volcano's vent, the force from breaking rock can induce a significant charge. As the plume ascends, the motion separates these charged particles. Generally, smaller, positively charged particles rise higher while larger, negatively charged particles remain lower. This separation establishes vast areas of positive and negative charge, similar to a regular thundercloud. The air serves as an insulator, but it can only handle so much. When static pressure escalates too high, the air's insulation deteriorates. The result? A substantial discharge of electricity, a bolt of lightning. This isn't a recent discovery. The earliest recorded observation traces back to Pliny the Younger, who described the eruption of Mount Vesuvius in 79 AD, noting the fitful gleam of torches at intervals obscured by the transient blaze of lightning. So, when you witness volcanic lightning, you're observing the volcano itself transforming into a geological generator. It represents a raw, fundamental blend of Earth's geological and atmospheric forces. The intense friction from the planet tearing itself apart fuels the fire in the sky. It serves as a powerful reminder that even amidst destruction, our planet produces awe-inspiring beauty. Conclusion. From the cosmic ballet of solar winds to the bioluminescent wonders of tiny organisms in our oceans, from the stunning, icy illusion of light pillars to the primal force of a volcano creating lightning, our world is brimming with spectacles that challenge our imagination. For centuries, we attributed these events to magic, gods, or omens. Yet the science underlying these occurrences narrates a tale equally magical in its own right. Understanding the physics of an aurora doesn't lessen its beauty. Learning that bioluminescent light signifies a microscopic plea for survival doesn't diminish its wonder, it adds depth and new appreciation. Science unveils the unseen connections, universal laws, and beautiful logic governing our universe. Our world is indeed a masterpiece, and science enables us to grasp the artist's technique. So, the next time you encounter something striking and inexplicable, don't settle for mere admiration. Cultivate curiosity. Keep looking up. CTA for further explorations into the science of our astonishing world. You know what you need to do. And while you're here, ensure that you're subscribed and have that notification bell activated. Now, I'd love to hear from you. What's the most breathtaking natural phenomenon you've ever witnessed? Share your thoughts in the comments below. Thank you for watching.